Hi everyone, we'll be waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the attendees who are in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. My name is Valen Kolika and I'll be your host for today. A few reminders before we start. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions in several languages are available during the live broadcast. You can enable this by clicking on the CC button located at the lower right corner of your screen. Feel free to ask questions at any time, but typing them in the live event Q&A window simply by clicking on the Ask Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously. You can do so by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Network Security Forum at aka.ms/Azure Network Security Community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. Now, we'd love to hear your feedback on how we can improve these webinars, and you can do that at aka.ms/security-webinar feedback. I would also like to take the opportunity to invite you to join our public community by visiting aka.ms/security community. This is the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, for which you can sign up at aka.ms/securityprp. You can request features, you can give feedback, review our product roadmaps, register for events, or join webinars like this. We believe that the best way to improve our products is simply by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Ashish Kapila will guide us through the advanced architecture of Azure Network Security. Ashish is a senior program manager with our Azure Network Security team. And without further ado, I will turn it over to him. Ashish, the floor is yours.
Thank you, Valen. Good day, everyone. As Valen said, today we will be covering Azure Network Security from an architecture use cases perspective. And my name is Ashish Kapila. I'm the Senior Program Manager, and I work with the Azure Engineering team. So moving ahead, so when we talk about the architecture, I want to just first briefly talk about Cloud Adoption Framework, which is just like a collection of documentation, implementation guidance, tools, and best practices from Microsoft, and that can help you to accelerate your cloud adoption journey. So these are like reference architecture based on the best practices from our side. So from a network perspective, this is one of the architecture which we see with many customers using, which is our hub and spoke topology. And as you can see, there is a high level overview where you have your hub and you have spokes connected to it, including your on-prem infrastructure as well. From an expanded view, you can see that in the hub network, you can have multiple workloads. You can have shared workloads like your Active Directory domain services, DNS, your management servers. You can have a perimeter network which is connected to internet, and you can have a perimeter network which is connected to your on-prem. And you can have other infrastructure like your DNS servers and other things which you can have in the hub network. But this is from a shared services perspective. And then you can see the spoke 1, spoke 2, they're connected to hub virtual network using the virtual network pairing. And we'll go through what you can have in a hub and what you can have in the spoke network. But this is just to give you like an overview as to how the hub and spoke topology looks like from our cloud adoption framework perspective. Right. So cloud adoption framework from a hub perspective, as I said, a hub is like a central network where you can have all your security controls. You can have your shared services like your Active Directory services. You can even have your management servers, which you can use to connect to your resources in Azure. The benefit of using a central hub network is the overall cost, because you can have a central network which can communicate with your on-prem networks and your spoke network. So if the spoke has to communicate with on-prem, or if on-prem has to communicate with spoke, you can have a central network where you have all your security controls and you manage that. So you're not creating separate security controls or security or separate VNets or separate spoke networks. You can have just one central network where you have everything. What can you have in a spoke network as highlighted here? You can have multiple or different type of workloads. You can have workloads specific to like infrastructure as a service. You can have PaaS services in a different spoke. You can have workloads based on your deployments like your dev, your test, UAT, or prod. And you can kind of control the communication between spoke network itself using NSGs and ASGs as well. So moving on, so what we're going to cover here is just from a network security design perspective. So I'll just go through one of our decision tree when it comes down to what you should use, whether you should use application gateway with web application firewall, whether you should use Azure Firewall, or whether you should, or where do you place if you're using both application gateway with web application firewall and also Azure Firewall, where do you place your resources or your security controls. So the basic difference here is that if you're trying to publish one of your web application onto internet, and you require the source IP from a logging perspective, or that's like your application need to see the source IP. then in that scenario, what we recommend is you put application gateway before the Azure Firewall. So what that really means is that Azure Firewall is your egress from internet, and from Azure Firewall traffic goes to application gateway. If you do not care about the source IP, then you can have your Azure Firewall in the front and application gateway behind it. So yeah, so it depends, because Azure Firewall will NAT the traffic going to application gateway, and we'll cover these scenarios a bit more. So this is the most common architecture which we guys or which we have seen customers using, which is your Azure Firewall and application gateway WAF in parallel. So what that really means is that for web applications, you're using application gateway with WAF, and for your non-web applications, you're using Azure Firewall from an ingress perspective. For egress, you're using Azure Firewall. So that is like they are there, but they are parallel. So they are not sharing the same or sharing the same application traffic. So as you can see over here, that when client has to access a web application, it has to go through the application gateway and then to the application application. And when application returns the traffic back to the client, it goes through the Azure Firewall, the application gateway here. And as I said, for any non-web application, if you want to publish it using, if you have to publish it to the internet, you can utilize Azure Firewall there. Right, so this is another scenario where you have the application gateway WAF before the Azure Firewall. So I'll talk about what are the benefits here if you have application gateway WAF before Azure Firewall, and like why would you use it? So as you know that today Azure Firewall doesn't have any geolocation or geolocation rules, right? So if you want to say that I do not want to allow traffic coming from China or India or Russia, a specific geolocation, you cannot control, you cannot create a rule on the Azure Firewall for that. Whereas with an application gateway, you can have geolocation rules. So if you're looking at geolocation rules to create, then you can use application gateway WAF before the Azure Firewall. Plus, if the application gateway is in front of the Azure Firewall, you also get the source IP address from the client's perspective. So you have the logs and you have the original client IP connecting to your application from an application gateway perspective. You won't get much benefit from an Azure Firewall in this scenario. It will still be just doing a point-to-point mapping. So when the traffic from application gateway or from an internet client hits the application gateway forwards it to the Azure Firewall, and from Azure Firewall it goes to your application. And when the traffic goes from Azure Firewall to your application, it's just a point-to-point mapping, because we do not do SSL offloading on the Azure Firewall. This is the third scenario where you have application gateway WAF after the Azure Firewall. The benefit here is that if the Azure Firewall is in front of the application gateway, when a client tries to connect to the Azure Firewall has threat protection inbuilt, which is based on our Microsoft Security Graph. So if a malicious IP is trying to connect to your application, that traffic will be dropped at the firewall itself and will not even get to your application gateway. So you're getting that protection here. But the downside is that any traffic which is coming from the client to the Azure Firewall, and when it goes to the application gateway, the traffic gets natted by the Azure Firewall's internal IP. So you lose the original client IP when it gets to your application gateway. So there is a downside with it. And as I said, the most common architecture which we have seen customers using is having application gateway and Azure Firewall side by side, and using Azure Firewall, using application gateway for the web applications and using Azure Firewall for both ingress and egress. Right, so this is an sample architecture here where we are using multiple technologies, and the main one which we are going to cover is our front door. Over here, as you can see that in this architecture, we have a website published on a front door, which is contoso.com, which also has like files as well. And that is kind of load balanced using traffic manager. So if a client is trying to connect to files.contoso.com, that request hits the traffic manager. And based on the configuration, the traffic manager will forward the request either to region 1 blob storage or region 2 blob storage. Whereas with when a client is trying to connect to www.contoso.com/store/star, so anything after this or anything which is under the store, then that request from front door goes directly to an app service instance. Right, so anything which is going to a store, the URI store, then that request goes to your app service instance. Whereas all other requests, for if a client is trying to connect to, for instance, www.contoso.com, then that request goes to your application gateway, and application gateway forwards it to your VM scale set, as you can see in this here. And the other interesting bit here is that when a request going to www.contoso.com/images, then there is another path which it will take. And based on that, so this is just to highlight how you can publish the same website, but you can have path-based routing through front door and application gateway based on your requirement. Plus, you can have a WAF protection for this application, both at the front door level and application gateway level. And over here, you can see that the databases are replicating as well between the two regions. Right, so the next one is how DDoS comes into play. We'll have an overall architecture as well. But from a DDoS perspective, as you know, that it protects any public IP which you have in Azure from a layer 3 and layer 4 DDoS attacks. In this particular architecture, we can see that there is ASC, which we are trying to publish, which we are publishing using application gateway. The benefit over here is that your app is not directly connected to internet, and the traffic is going through your application gateway, and the public IP which you have, which you're protecting from a DDoS perspective, is on the application gateway. So when a request comes from internet, you have the DDoS protection to protect you from a layer 3 and layer 4 perspective on the application gateway itself, and all the traffic going from a layer 7 perspective is protected by the WAF before it even hits the app services. Right, so this is just to highlight the hub architecture with cloud native controls which we have. Again, this is what we discussed earlier, the hub and spoke topology, where you have all your security controls. So as you can see in this, in the core services or a hub VNet, you can see you've got your firewall. It has a public IP. You've got a web application firewall, which is on a separate subnet protected within NSG, has its own public IP, and both of these public IPs are protected from a DDoS perspective. You have your hybrid connectivity, which is through your express route to your gateway subnet. And then you have other subnets like management subnet or your Active Directory services which you have in here, or DNS, which you can have NSGs to control the traffic. So this is like an overall design from an enterprise perspective. Again, this is for reference. Based on the requirements, you will have your own architecture. But what we are trying to show here is that a hybrid cloud infrastructure. And again, the main point here is that under the core services, which we discussed earlier, you've got DDoS protection, protecting your public IPs. You got your firewall protecting any ingress or egress from your spoke networks or from your hybrid, or sorry, from your on-prem. Plus you've got the WAF as well. And you can see over here that you have got two separate perimeters network setup. One is where the internet or the extranet is here, and over here is your intranet, which is your hybrid infrastructure, and you've got that kind of logical or segmentation here between your hub, which is your shared services virtual network. And over here you can see that multiple spoke networks are peered with hub directly, and all these have different applications. You can have your dev, as you can see, you can have your dev VNets, you can have your test VNets, prod, and everything is peered to your hub, and you can control all the traffic flows through it. The main thing is that VNet peering is the key. All your spokes has to be paired with the hub so that you can have control all the traffic flow between the different VNets, and including your on-prem infrastructure. Right, so we'll just go through a little exercise here, in the sense we'll try and build the perimeter from the scratch. Before we start to do that, I just wanted to highlight the slides as to how the defense in depth using the network security controls. As you can see right in the middle, you've got your Azure deployments like your infrastructure as a service or PaaS services, and over here is your internet. As you can see, the first line of defense which you can have is the DDoS protection, which will protect all your public IPs against layer 3 and layer 4 attacks. Then based on the architecture which you're following, you can have either a public load balancer, or you can have a web application firewall on application gateway, or you can have side by side an Azure firewall as well. But again, based on the architecture which you're going. But all these parts, as you can see, they're individual controls. So it helps you with any kind of cascading failures if you have. And then once you have your Azure firewall, the next one which you can have on a subnet level is NSGs. You can have NSGs on the subnet to protect any communication from subnet to subnet, or and then you can also have NSGs on NIC as well, where you can define the rule what is allowed from a NIC communication perspective. And then you can have individual firewall, either like a Windows firewall on a VM, or like a SQL server-based firewall, a SQL server firewall, or a PaaS service firewall, before it can get to your resources. And all these controls are individual controls. And if you are utilizing all that, then it's like you've got a defense in depth kind of a scenario, where every security control is taking care of the communication based on what you're allowing and what you're not. So based on this, when we try and build the perimeter, what we are just showing up here is just your application stack without any security controls, which means that bots or your legitimate users, or your bad users, or any kind of data exfiltration attacks can connect, or all these resources can connect to it, because there are no security control. And this is where we start putting our cloud native controls one by one. As you can see, the first one which we have is our Azure Firewall and service endpoints. So Azure Firewall can control the communication. You can control all the traffic flows from layer 3 to layer 7. And you can restrict any access from an egress and ingress perspective through Azure Firewall. And service endpoints can be used to protect any kind of access to your public PaaS services. You can use the service tags in the Azure Firewall as well if you don't want to use the service endpoints, and that way you can protect your PaaS services through the Azure Firewall. So anything which needs access to the PaaS, like your Key Vaults or your Cosmos DB, you can kind of let the traffic go through the Azure Firewall, and you create the rules on the Azure Firewall to allow or deny access. Now, if you have web applications as well, then you can introduce the application gateway with web application firewall. What it protects you is it protects you from any bots trying to connect to your or bad bots trying to connect to your application. It will only allow the legitimate access. Plus, you can have Azure DDoS on top of that, and Azure DDoS again will protect Azure Firewall and WAF from a layer 3 and layer 4 attacks. So this is from a single tenant perspective. If you have multi-tenant, or if you want a global WAF, then you can introduce the WAF on the front door service. And as you can see, that front door is right outside the hub virtual network, as it's a global service. It protects your application from the layer 7 attacks. Plus, it gives you application acceleration, which means that if users are if the application, for instance, is somewhere in US and users are based globally, then the connection from a user based in, for instance, in India, will connect to the local Azure data center in India, and that traffic or that request will go from in India to US over your Azure data center or Azure network backbone. So it's not traveling on the internet, so you get that application acceleration benefit as well. So I've got a couple of architectures here which we can go through. The first one which I have, as you can see, is using Azure Firewall in a virtual WAN scenario. So virtual WAN is basically kind of a central, or is a managed service provided by Microsoft, or it helps you to centrally manage all the network infrastructure which you have in a virtual WAN. So you're like site-to-site connections, point-to-site, and everything, like express route and all those. What you can do is you can introduce Azure Firewall to secure the connections or the connectivity. And basically, from an Azure Firewall perspective, you can secure like VNet to VNet communication, or you can secure like VNet to internet communication. Plus, you can have like branch to internet scenario, which you can secure using firewall. And if you are planning to use like a third-party security as a service, for instance, Zscaler or iBoss, then you can protect that access as well using the firewall as well, Azure Firewall and the Firewall Manager. The advantage of using virtual WAN and Azure Firewall is the automated routing, so you don't have to individually go and define UDRs on the VNet. And with one click within the Firewall Manager, you can control access to your private traffic or internet traffic or third-party traffic. So you can define all that, and it's easy. It's automated as well, and you can manage like multiple firewalls, as you can see in this instance here. The next one is an architecture which is using AKS for AKS with Azure Firewall. As you can see over here, that you have got an AKS cluster and you got an Azure Firewall. What this AKS cluster we have is a UDR, which says that if you're connecting to 0.0.0, go through your Azure Firewall, which means that anything going from AKS to internet is secure with the Azure Firewall. Plus, you can also use Azure Firewall to publish your AKS cluster using DNAT. And for that traffic, you can see that when a traffic from internet trying to connect to AKS will go through Azure Firewall, and from Azure Firewall, it will go to a public load balancer, and from public load balancer, it will go to the AKS cluster. So you can control both outbound and inbound traffic from an AKS perspective. From a policy management perspective, we have FQDN tag for AKS, which you can utilize to allow access to your AKS cluster as well. So it makes it easier. The other tool or network security tool which you can use if you would only like to have egress of AKS cluster to go through Azure Firewall, but for the reverse proxy or ingress perspective, you can utilize application gateway. So what that means is that anything which is going to internet from AKS cluster will go through your Azure Firewall, but anything from internet trying to access AKS will go through your application gateway, and then using the ingress controller which we have, that will connect to the AKS cluster. So you can protect your AKS cluster or your application from with WAF from a layer 7 perspective as well. So this is quite a recent one. This is to protect your Windows virtual desktop with Azure Firewall. So as you can see over here that you've got a customer hosted virtual desktop pool, and you've got your Windows virtual desktop service over here. And again, from hub VNet, you've got an Azure Firewall sitting in the middle. So on the host pool, again, you can define a UDR to force all the traffic to go through Azure Firewall when it has to connect to Windows virtual desktop. So you can create again, you can use the FQDN tag for Windows virtual desktop in Azure Firewall to say traffic from your host pool going to Windows desktop service is allowed. The benefit here is that you do not have to maintain the list of IPs for Windows virtual desktop, and you can utilize the FQDN tag in the Azure Firewall itself. Plus, you can control any internet access as well. So you can utilize the application rules, network rules, and the threat protection to protect any outbound access from the host pool network going to internet. So yeah, so that's pretty much what I have. I'll give it to you, Alan.
Perfect. Thank you. Thank you. And the team here is answering questions, but we do have some for you. So let me actually give a chance to the audience to type them in our polling, and I will share the polling here with you shortly. Just a second. So here's the link in the IM, and then let me share the screen. So it's a polev.com/security webinar, and we'll take this opportunity to ask a question to Ashish. There we go.
Don't X forwarded for header work with app gateway, so it can be used behind Azure Firewall or any other NVA to obtain the client IP. So if the clients are going to add that header, which I do not expect, then in that case, you won't have the X forwarded for header here. So if the application gateway is behind the Azure Firewall is not going to add the X forwarded for header. So if the client, whatever the client application, if it's going to add that header, then that's a different story, which I'm not aware of. So yeah, so if you really need the source IP, then the application gateway should be in the front of the Azure Firewall. When will intrusion detection be available? So we have a private preview running, and I'm sure Valen gonna share the link, which you can utilize to get more information around that. Will the AKS example fit other platform like OpenShift? So if you have the capability in OpenShift to define UDR, saying where you can force any outbound traffic through a Azure Firewall, then yes, it will work in that scenario as well. Will these patterns also be in the Azure Architecture Center? Yes, there is. This is available. So the 3 scenarios which I discussed, where you have the application gateway parallel to Azure Firewall, application gateway behind Azure Firewall, and application gateway before Azure Firewall, they are all there, and we can share the link. What network security use cases and pattern exist for cloud native end-to-end PaaS? Therefore, no VMs. So from a network security perspective, you can protect all like app services at least from using application gateway WAF or front door WAF. So from a layer 7 perspective, if you're planning to use application gateway, then you can protect your resources against layer 3 and 4 attacks as well using DDoS. Same with CDN as well. For storage and functions and SQL databases and other PaaS services, you can use Azure Firewall and service tags to allow access to those services. Plus, you have the private link as well, which you can utilize if you're worried about these PaaS services, and then you can utilize that. How do we allow specific users inside one WVD host pool to access one FQDN? So this is not possible with Azure Firewall, as it's not aware of identities as of now. But I haven't looked at the WVD host pool myself, but I don't know if there is some kind of policy which you can create where you can have individual group allow access to specific things. But we do have on our roadmap from an Azure Firewall perspective, where we are looking to have user awareness and application awareness for Azure Firewall. In terms of cost, which costs less in terms of deployment? So that's where I was discussing the hub and spoke topology. So hub is like your shared infrastructure, which is used with all your spokes plus your on-prem, and it's like a centralized shared VNet where you have all your security controls. So you're not creating controls on individual VNets, you have that centralized, and that's where you have the cost saving. Do you have some reference architectures documented? There are lots of reference architectures. You can either find it on our on the website itself, and there is the cloud adoption framework as well, where you can find all the best practices and the reference architectures.
Okay, great. This brings us to the end, and with today's session, we're pretty much wrapping up the calendar year with our public webinars. And if you would like to visit us on our aka.ms/security webinars landing page, you'll find out more about the upcoming webinars starting in January. And in case we missed to answer your question, or if you have additional questions, you can visit us on our Azure Network Security Forum at aka.ms/Azure Network Security Community. I would like to close this webinar by thanking Ashish for another excellent presentation. And thank you to the rest of the team who did a great job by answering questions. And most of all, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye until January. Bye.